functionally verify our design using simulator before specifying a target PLD to implement them. Rapid prototyping. So this is the biggest PLD design methodology can be used for proof of concept to rapidly prototype and implement a system in small quantities to provide its viability. Next is VHDL programming. So before that, we need to know about the comparison between the different model conditions. We will see the one by one. There is behavioral modulation having it consists of sequential programming statement. It requires truth table for design. It represents behavior. It consists of gate level abstraction. It is expressed in the sequential big state process. Data flow. It consists of concurrent statements. It requires Boolean expression for design. It represents behavior. It consists of gate level abstraction or algorithm. The view of data flow as flowing here, design from input to output, and structural modeling. It is set of interconnect component. It requires logical diagrammed for design. It represents structure. It consists of RTL abstraction. The view is closest to hardware. So this is a structural concept. These are the points we need to know about these models, that is behavioral, data flow, and structural model for execution. This is the syntax for VHDL programming. So first port, end, and begin, end behavioral is the behavioral modeling. This VHDL code for AND. First we need to get the library from IEEE, then use the logical and arithmetic and unsigned library also we are using. So first entity is gate AND gate is port A, port B, and port C. Here we are defining the port value input A. It's the input standard logic, B input standard logic, and Y output standard logic, and finally end AND gate. So architecture behavior of AND gate is begin, that is Y less than or is equal to A and B. That is AND of A and B will store to the Y. This is the end of behavioral model. Same or same as we are getting the triple, that is input A and B we are getting as assigned as a input and Y assigned as output, and we begin with the Y A and R with the B. So it is a end behavior. Same as NOR gate, NAND gate, and XOR gate and XNOR gate. Okay, next half adder using behavior modeling. Okay, first we need to define the begin with the sum. Sum is equal to A XOR B. Carry is equal to A and B. This is a half subtractor code, full adder code, full subtractor code. So next we will the types of statements using if and else conditions. Okay, that is a multiplexer condition is a implementation of 4:1 multiplication. In left side, we have the initialization and the input and output. So for 4:1 multiplexer, we need to define the select lines. Okay. So select lines is that is 4 input, 1 output, and 2 select lines. Okay. So D in representative, that is input. Okay. So this input represents a 3 to 0. So 3 is to 0 means it is a 4-bit input. So selection having 1 and 0, 1 down to 0, that is 2-bit data. Then D out is a logic 1. So output is 1. So that is the 4:1 mux. Okay, first begin with if 0 0, then D out is equal to D in is equal to D out. That is, if selection pin is 0 0, you have to put D3 pin as a D out. If select is 0 1, you have to pin D into the D out. Then 0 0 means you have to put D1 as the output. Next other condition, there is no condition. That means condition means you can get the 0. Otherwise, if condition is 1 1 means you will put the output to the 0. That is the end if process condition. This is using case statement. That is they are using the when and case statement there used. Else statement with mux using a else statement. Okay. So these are the points we discussed in this concept. In Unit 5, we discussed about the more number of programming, that is structural modeling, behavioral modeling, and then like synthesis process, very large scale, bigger scale like that we discussed. So the program part is very important. So in the university format, they will ask the one word on the particular behavioral model, the structural model programming and other sums like that. They need they define a question, design a question for define the or design the half adder, half subtractor, half full subtractor like that they will design. You have to draw the image and you will get the output. Okay, this is the concept we discussed in the unit 5. So overall, unit 1 we have the basics of our number system. So that is number systems, types of number system like that we discussed. In second half, we discussed about the digital logic family, that is TTL, ECL, DDL, like that we discussed. That is transistor logic, like that we discussed. Then unit number 2, it is a combination circuit. So we know that the combination circuit means output depend on the present input. Okay, so in this unit we discussed about Boolean expressions, Boolean laws, Boolean function reduction using K maps. So then combination circuit applications, adder, subtractors, multiplexer, demultiplexer, encoder, decoder, code converters like that we discussed. In unit number 3, that is synchronous sequential circuit. In this unit, we discussed counters and shift registers. That is one of the example is sequential circuit is flip-flops, counters and shift register. That is, these are all connected with the common clock pulse means it is a synchronous. If not connected with the common clock pulse means it is a asynchronous circuit. Okay. Then unit number 4, we discussed about asynchronous sequential circuit design as well as the programmable logic devices. Programmable logic devices. In unit number 5, we discussed about VGSTL Verilog programming and modeling, different kind of modeling as well as the Verilog programming used in this unit number 5 like that we discussed. I hope you all know about the basics of digitals. This digital will implement in the any of the digital system which is you have to use in the future. Okay, thank you all.